Alrighty, who's ready for some chapter 3 kind of fun? Here we go. 3.1, Writing and Graphing Inequalities. Okay, so an inequality, essentially, it's just a mathematical sentence. It's just going to use some different symbols than we're a little bit used to. Or maybe you are used to them and you've learned about them before. Hopefully everyone's at least worked with them a little bit. It contains the symbols that look like, little caret deals going from left to right, greater than, less than, those types of things. And they all correspond to different phrases. So the is greater than or is more than phrase responds to, oops, not that one, just that simple symbol. The is less than or is fewer than phrasing responds to the less than symbol. The is greater than or equal to uses that greater than or equal to symbol, and is less than or equal to uses the less than or equal to symbol. Some other synonymous phrases for is greater than, something like is at least or is no less than, and some other phrases for is less than are phrases like is at most or is no more than. Just other different ways to say the same thing, basically. Now, when we go about graphing these types of sentences and expressions, we're going to be doing them two different ways. The first way, and the way that we're going to worry about right now, is on a number line, which is simpler. And when we do things on the number line, we also have some different symbolic usage on there. So when I'm plotting a specific point and it's going to be greater than, I'm going to use an open circle, and then I'm going to attach an arrow to that, and I'm going to point that arrow to the right. If I'm saying is less than, I'm again going to use an open circle, but I'm going to attach the arrow to the left. If I'm talking about is greater than or equal to, we're looking at a closed dot, but still going to the right, and is less than or equal to, closed dot, and going to the left. Now, let's take a look at example 1, which is essentially asking us to use the phrasing and to convert that phrasing into a mathematical sentence. So a number W, easy enough, W, minus, this is easy, 3.5, come on, this is child's play. Give me something harder. Is less than or equal to? Alright, they kind of threw me one there. Is less than or equal to, let's look at our chart. Is less than or equal to, that means I'm using boom, 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 -2. Huh. Simple. No big deal. Alright, that's all we had to do for example 1. We don't even have to do anything with it. We just had to write it in there. Now let's take a look at where we go from here. A solution of an inequality. We're going to start looking at those. Solutions of inequalities are values that make the inequality true, just like the solution of a mathematical equation is what makes the equation true. An inequality, however, can have more than one solution. The set of all solutions of an inequality is called the solution set. Alright, so let's take a look. In this table here, I'm looking at this inequality. X plus 5 is greater than or equal to -2. And I'm going to choose some values of x. And given those values of x, I'm going to test them out. I want to see, are they part of the solution set? Do they make the inequality true? Okay, so we have one done out already, -6. -6 plus 5 is -1. -1 greater than or equal to -2? Yes. So -6 is part of the solution set. Let's try something like 4. X plus 5 greater than or equal to -2, so that means 4 plus 5 greater than or equal to -2. Is 9 greater than or equal to -2? Yes. Now let's try something like, I don't know, -8. -8 plus 5 greater than or equal to negative 2. Negative 8 plus 5 actually gets me a negative 3. Is negative 3 greater than or equal to negative 2? No. It's less than negative 2. So that's a no. In example 2, we basically want to do the exact same thing, but we want to check to see if negative 4 is a solution of either of these two inequalities, A or B. So I'm just going to plug them in. Negative 4 plus 8 less than 3. Negative 4 plus 8 is going to come out being a 4. Is 4 greater than 3? Is 4 less than 3? Not in the world that I grew up in. And negative 4.5x greater than negative 21. Let's see, negative 4.5 times negative 4 greater than negative 21. This right over here on the left side is going to turn out to be an 18. 18 greater than negative 21? Absolutely is. Looks good to me. Alrighty. The graph of an inequality shows all solutions of the inequality on a number line. So this is where we're going to use those symbols, those arrows and those dots like we saw in the beginning. What I want to do is graph the inequality y is less than or equal to negative 3. So what I need, obviously, is a number line. And what I'm going to do is kind of center the point that I'm looking at, negative 3. I'm going to choose a value to the left of it, negative 4, let's say. Choose a value to the right of it, negative 2. Just so that I can kind of figure out exactly where I am on this number line and get my bearings left and right. Now, when I want to graph the actual solutions, all solutions of this inequality, I need to kind of go back to my chart. I'm looking at y as less than or equal to negative 3, which means less than or equal to, I'm going to do a closed dot, and it's going to point to the left. I'm going to do a closed dot on negative 3, and it's going to point to the left. So everything that is a solution, this goes on forever, everything that's a solution is going to be colored in. So a number like negative 2 is not a solution. A number like negative 4 is a solution. A number like negative 3.2 is a solution. A number like negative 2.7 is not a solution. Hopefully this was not too painful. And when I see you guys in class, you will have questions for me. You will have them written down. Good luck with the assigned work, and I'll see you guys later.